And it's a good practice paper. It's something that I imagine you're going to look at maybe even when you do the mini check, but let's look at it now. I tried to swing around and talk to you guys about some of the problems that are not up here. Here's some things that maybe I didn't get to share with you. We're going to use number 9 as sort of the segue into this little wrap-up lesson. So when you guys are ready, we're going to basically start with number 9, but are we okay with other things? I think I've talked with most of you that you want to be looking for the branches. When you have a slant, you're going to have a branch somewhere in one of these quadrants. It turns out that it's in this lower left and upper right quadrant. You always want to be looking for something on each side of the asymptotes. This problem has lots going on. It's an interesting problem. We do end up with x-intercepts at plus or minus root 2 and a y-intercept at 3/4, which allows us to draw this branch in the middle. But then you have the horizontal asymptote working itself with the ends of the graph. I'm getting a sense that we're okay. So I'd like to talk about this. There's a hole in the graph. Okay, just like there's a hole in the bottom of the sea, there's a hole at -3, -1/8. Now, we haven't talked about the -1/8, and we haven't talked too much about the -3. It's popped up a couple times. So I'd like to kind of work through this problem as if maybe we've never seen it before, or you have seen it before, but I'd like to kind of work through it in a bit of a fresh way and make sure we understand how we can get every one of these parts to this answer. If you want to, you can just watch, especially if you already got it right, if you want to take notes on it. But again, I kind of just want to look at this problem with a fresh perspective. It definitely is rational. I know that's kind of obvious, but the reason I say that is because we want to go back to the basics, which is the denominator. Okay, any problem that has a denominator needs to be analyzed. And so, bless you, I would imagine that you would factor this because that's the easiest way to find those bad numbers. And we recognize that 5 and -3 are bad numbers. Now, the reason I'm just going back to those basics is because that means that both those x values are undefined. That means they're going to be a problem on the graph. They're going to show up as some kind of problem. Okay, but as I know you've heard, but now we just want to kind of revisit, if you have this repeated factor, well, that means there's actually going to be a hole at this problem. Now, right now, sort of before we go any further, we make this conclusion. We say that there's a hole at -3. Again, because there's this repeated factor. But a hole is like a missing point, and a missing point is still an x and a y. So we have this interesting observation how we can find the y value. In fact, you see how we can get -1/8. You're not going to get it on your calculator because your calculator is just going to give you a big blank. Well, as some of you have said, don't these cross out? Or as you look at this, shouldn't they cross out? Well, I'd like to say that if you cross them out, you end up with what I call a temporary version of this equation. But the thing about that version, 1 over x minus 5, it's able to accept with open arms the problem. Okay? It's able to accept -3. In other words, we're able to plug in -3 into this temporary equation. Do you catch my drift? Some sort of just dry humor, but you can plug in -3 to that version. It doesn't give you a 0 in the denominator. And what it actually gives you is what would have been the y value. In calculus next year, you'll call that the limit. But it gives you what would have been the y value. And it allows us to write this whole as a point, as a true x and y point. Now here's the thing that and it's a little theory, okay? Here's the thing that you want to understand. I just crossed this out temporarily. The reason I say temporarily is because it's still part of the equation. You say, what does it matter? Well, if it wasn't part of the equation, then I just would have put this problem on your paper. And if I just put this problem on your paper, there's no hole in the graph. So you have to understand that this problem is different from this problem for one reason, because there's a hole. Okay, but we can still think about sort of the equation without the hole so that we can end up with this y value. The rest of it's kind of business as usual, but you want to make sure that you don't forget about 5. You want to make sure you don't forget that that's a vertical asymptote. You want to make sure you don't forget about the horizontal asymptote. I like to go back to the original equation so I don't get confused with what I'm doing over here. The original equation says y equals 0. And you don't want to forget the y-intercept or the x-intercept. I know they're up here on the screen, but the y-intercept is still back to the original equation, 3 over negative 15. 3 over negative 15, of course, though, is equal to negative 1/5. And come back with me here for this x-intercept, because sometimes this is the one thing that gets confused. The x-intercept is supposed to be what makes the equation equal 0. As we've talked, a lot of times that's just the numerator for a simple problem. But we got a problem, because if you tell me that negative 3 is an x-intercept, then we're kind of in conflict with the whole. In other words, we can't have negative 3 comma 0 and negative 3 comma negative 1/8. So negative 3, we still want to remember bad number. Bad number. Sorry, bad number. You're not an x-intercept. You're not a point. You're a whole. So there's no x-intercept. To say it another way, you can't have a whole and an x-intercept at the same place because they're two different things. Again, an x-intercept is actually a point. So a hole in the graph. I just like my little graphic there. But, well, not but, you already wrote down, you did already write this down. Maybe you just want to look at it. That hasn't changed. Okay, numerator, denominator, common factor. This, though, might be something you want to process and decide if you want to write it down. I don't want to make it complicated, but I want to make sure you understand what I did do, which was to find the exact x and y value. And if somehow you want to write this back with your notes that you took on a whole, to get the exact x and y value, remember how I crossed out the whole, or excuse me, I crossed out the common factor. I made a temporary equation so that I could plug in x and get y. So we got this idea of crossing out the common factor. What you're actually doing is you're crossing out the problem so that I can plug in x to that temporary equation and get y. I don't know. It's just bugging me because I put this problem up here. I know most of you graphed it and you don't need to redraw it. But if you did take notes on this, I just want to make sure that I'm showing that you do draw the graph. Obviously, it's the same graph I had up on the screen, but that's the whole point behind all this. Notice that the hole is actually in position at -3, -1/8, as well as the other points. Everybody's happy. We're going to do somewhat of a super problem. Sometimes on initial contact, this thing looks crazy, but some of the work's already been done for you, which is why this is a nice problem. It kind of helps you realize how you use each and every part. So we have x minus 1, x minus 2, and in the denominator we have an x minus 3 squared, and an x minus 1. And then at the very end, a plus 2. We're getting to the point where we're kind of wrapping up this concept, okay? But we want to be able to apply it to super problem. I wouldn't be surprised if some of you can jump in here. I'm just pausing in case you want to do some thinking. Maybe you just want to listen to so you don't go in error, but I'll just kind of share that this is good thinking. I always like to start with this. Before I get carried away with other things, I just want to note the bad numbers. Make sure that these bad numbers end up on my list. The other thing is that none of those numbers had anything to do with the numerator or the plus 2. Again, we just want to keep things kind of straight that those 3 numbers end up on our list. Now, we have to be careful that they end up in the right place. And it does become true that the hole in the graph kind of like overrules. In other words, x equals 1, this common factor that we see, it has to be a hole. So you probably should start with that one, even though it's the last thing we've talked about.
One. I thought it was an I, and I was like, come on, man, on our first example.
What, right here?
No, the one in the numerator, it looks like there's like a little chunk out of it, so it looks like an I.
Okay. Chalk must have spun in my hand or something. Everything's real. Thank goodness they're all real numbers. Now, it depends on what you want to do. Maybe you just want to cover it up. Maybe you do want to rewrite it. I'm going to rewrite it. But the version of this equation, the, so to speak, temporary version, is the version that has the x minus 1s canceled out. So I can kind of comfortably, safely work with this version, mainly plugging in 1. Plugging in 1. Notice that the plus 2 is now part of this, as plus 2 is going to give me a shift on the y value, which is really what's going to happen right here, right? We're going to find a y value. What do we get here? -1 over, I don't know, -2 squared, so that's 4. So we get -1/4 plus 2. -1/4 plus 2. Okay, you know, if you had to do this without a calculator, you could decide if you're going to write that as a decimal, or if we're going to do a quick little common denominator, 8/4 turning into -1 to be 7/4. You're not going to find that number on your calculator, so you're going to have to be able to, again, do a little bit of this algebra of crossing out. Questions, because that's the main new thing. Are you sure? Okay, cross them out, plug in 1, do the math, it's 7/4. Now, don't forget about the other things, like those other bad numbers. Here's the reality. x equals 0 and x equals 3. There's nothing else that they can be. They are going to be vertical asymptotes. So it's all right. You're not like overlooking something. There's nothing else they can be. They would have to be verticals. Horizontal, interesting step in this problem. You know that it has to do with degrees. I don't know about you, but I don't really want to FOIL all this out so I can see the degrees. But I'm not quite sure we have to FOIL it all out to realize that eventually you're going to get a 1x squared in the numerator. And in the denominator, to kind of look at the degree and realize that eventually you're going to get, well, it's going to be a 1 because there's no coefficients, but I'll have x to the 4th. I don't need to FOIL it out to see that I'm going to end up with the top being the top being smaller than the bottom. So we end up with the rule being y equals 0 plus 2. Y equals 0 plus 2, which ends up being 2. Remember, the plus 2 is going to shift that asymptote. All right, x and y intercepts. Probably going to be helpful to just go back to the original equation before you crossed anything out and just plug in 0. But, your eyes should say, wait a minute, if I plug a 0 in for all these x's, this one right here is going to be a bad place. I can't plug 0 in, so therefore I can't plug 0 really into the equation. That means there's no y-intercept. Again, I can't plug it in, so we get a big none. Now the the x-intercept, this is going to be one of those problems where we say, I'm not going to expect you to find it. Careful, the x-intercepts are not just the numerator because I've got this plus 2 that affects it. So we're not going to expect you to find the x-intercept. When we look on the calculator, you'll see that it ends up being a random decimal. And let's do that. Let's make sure that our final step here is to take a look at the graph. Before I graph it on my calculator, I should prep it for all this stuff. Depending on how thoughtful you're being right now, you would say, yes, there's a hole in the graph. It's going to be kind of like in this space because it's at 1/7/4. So you can get that prep. There's no intercepts, though. There's no intercepts that we found. Know your calculator. Okay, double parentheses is required on my calculator's numerator. Maybe you have a calculator that is able to show that a little differently, but I have to use double parentheses. And I think you're realizing that, what I sometimes show on the chalkboard is not exactly how it looks on the screen. Sometimes you have to do some interpreting. This is definitely one of them. The graphs don't just stop. The reason they don't just stop is because of what an asymptote is. It's something that the graph keeps getting closer and closer to without touching it. Not going to really work like I want it to. I was trying to get it over top of it. But we do have this part right here. It does keep going up. Okay, this part in the middle, it definitely passes through the point, but then continues on its way down. Again, just because we know that it's not going to stop. And then we've got this guy over here. Okay. Now, I'm going to give you a mini check. It is not going to have a problem like we just did. That I hope you would realize that's not the way that I operate